friends, myself Dr. T. Sudarshan Ramaperumal. Today we are going to see about the introduction about the transport layer and UDP protocol. Transport layer. So introduction about the transport layer. Transport layer is a fourth layer of the OSI model and is the core of the internet model. It responds the service request from the session layer and issues service requests to the network layer. The transport layer provides transparent transfer of data between hosts. It provides end-to-end control and information transfer with quality of services. It is the first true end-to-end layer implemented in all the system. Transport layer is located between the network layer and application layers. The transport layer is responsible for providing services to the application layers. The services that can be provided by transport layer is process-to-process communication, addressing, encapsulation, decapsulation, multiplexing, demultiplexing, flow control, error control, and congestion control. Process-to-process communication. The transport layer is responsible for delivering data to the appropriate application process on the host computer. This involves the multiplexing of data from different application processes. And together with the source and destination IP address, the port numbers constitute the network socket. And the transport layer protocol. These are the major three protocols used in the transport layer. One is user datagram protocol, UDP, TCP transmission control protocol, and stream control transmission protocol is SCTP. Each protocol provides a different types of services and should be used appropriately. For transport layer protocol, UDP is an unreliable connectionless transport layer protocol, and TCP is a reliable connection-oriented transport layer protocols, and SCTP is a few new transport layer protocols. SCTP is a new transport layer protocol designed to combine some features of UDP and TCP. Then we go for user datagram transport protocol, UDP. User datagram protocol is a connectionless unreliable transport protocol. UDP adds a process-to-process communication. UDP is a very simple protocol, and UDP is a simple demultiplexer which allows multiple processes on each host to communicate. UDP does not provide flow control, reliable, and delivery. UDP data packet formats. UDP packets are known as datagram. These user datagrams have a fixed size of the header A byte, made up of 4 bytes of each 2 bytes. UDP continues. Source port number used by process on source host with 16-bit long. If the source host is client, then the port number is then temporary on request by the process on chosen by UDP. If the source is server, then it will be well-known port number. Destination port number, the port number used by process on destination host in 16-bit long. Length, this field denotes the total length of the UDP packet. The total length of the UDP is 0 to 65,535 bytes. Checksum is used to identify the errors present in the data packet. Data field defines the actual payload of the transmit. And services, connectionless service. UDP provides a connectionless services. There is no connection establishment by no connection termination. There are no relationship between the different user datagram even if they are used, coming from the same source process and going the same destination process. And checksum congestion control service. Some of the services provided by the UDP. Flow control. UDP is simply protocol. There is no flow control and no window mechanism. The receiver may overflow within the incoming messages. The lack of flow control means that the process using the UDP should provide for these services. Error control. There is no error control mechanism in UDP except for checksum. This means that the sender does not know if a message has been lost or duplicate. When the receiver detects an error through the checksum, the user datagram is slightly discarded. Thank you.